Hey guys, so going to show you a quick video here on more of what we did yesterday with balancing reactions, labeling who's oxidized, who's reduced, how many electrons are transferred. Then I'm going to give you a worksheet due tomorrow, but I'm only going to have you do a couple of them, and I'll do one with you here. So here we go. So Leo Gurr, lose electrons oxidized, gain electrons reduced. One new thing I'm going to introduce is called the oxidizing agent and the reducing agent. So an oxidizing agent gets reduced and the reducing agent gets oxidized. So I'm going to refer to this when I go over a sample problem here and then one of the problems on the worksheet. I'm really not too worried about this here, but I'm just going to introduce it. So if you remember it, great. If not, I'm not worried about it. So Leo Gurr is important. Lose electrons, oxidize, gain electrons, reduce. All right. So let me clear this. And let's do one like we did yesterday. So if I had, let's say, let's say calcium metal, Ca solid, reacting with aluminum ions, Al plus 3Aq, and that's going to produce calcium ions, Ca plus 2Aq, and solid aluminum. All right, so basically what happens in redox reactions is, and common redox reactions are synthesis, decomposition, single replacement. Those are common. So what actually is happening here is if you take something like calcium and react it with aluminum nitrate. So if this is a solution and this is a solid, when you put calcium in this solution, because calcium is more reactive than aluminum, higher on table J, we've talked about that. I'm not going to show you right now, but Ca replaces aluminum. So here, this is a solution. So this would be dissolved. That's what Aq means. Calcium replaces aluminum, and now it's calcium nitrate solution, Aq, and then aluminum solid. So in a single replacement reaction, the more reactive metal replaces the less reactive metal. So now calcium's with nitrate in solution and the aluminum would precipitate out. So this is really what is happening here. NO3, these are called spectator ions, NO3 minus. They don't have anything to do with this reaction. They don't have anything to do with losing or gaining electrons, it's just calcium and aluminum. So this is just kind of a short way to do it. All right, so now here we go. Just like we did yesterday. Solids, liquids, gases get 0. Now we have to figure out, all right, how do we balance this thing? Well, we have plus 3 on this side. Right here's plus 3 on this side. And we have plus 2 on this side. The next number they have in common is 6. So I need 2 here. That's plus 6. And I need 3 here. That's plus 6. So now charge is balanced, but mass is not. I have 2 aluminums. I have 1 aluminum, so I better put a 2 here. I have 3 calciums. I have 1. I better put a 3 here. So now 3, 3, 2, 2, plus 6, mass and charge balanced. All right. Now, oxidation and reduction. Calcium goes from a 0 up to a plus 2. So calcium gets more positive. That means it lost electrons. Here's my Leo. So my Ca0 is oxidized. It's really important you put the 0 charge because it's not Ca plus 2. Ca plus 2 is the result of the oxidation, right? It's always the reactants that we're focusing on. So calcium 0 is oxidized by default. Al plus 3 is reduced, and that's because it's gaining Gurr, right? Gaining electrons and becoming more negative. The charge is decreasing, reducing. All right. So now the total number of electrons transferred, 6 electrons total. Why? Because if there's a plus 6 here, there's got to be a negative 6 somewhere balancing it out. So what's basically happening is each calcium is losing 2 electrons. Each Ca is losing 2. Since there's 3 of them, that's 6 electrons. All 6 electrons are being transferred to aluminum. So from 3 calcium, 6 electrons are being given to 2 aluminum, 3 each. and then it goes down to a 0. Okay, now I'm going to show you how to write a half reaction. All right, so I need to keep my 3. I need to keep my 2. All right, so what is a half reaction? A half reaction, so that's what I'm going to be showing you here. Half reactions is where half of this reaction is oxidation, half of this reaction is reduction. So I'm going to show that. So 3Ca0 yields 3Ca plus 2. Nothing new here. I just take this and write it here. I take this and write it here. Now we have to show how that happens. The reason this is positive 2 is because the calcium 0 lost 2 electrons. So over here I have to show losing, exiting, right, exo on the right, getting rid of 6 electrons. Why 6? Each Ca loses 2. There's 3 of them. So that's 6 electrons total. The other reason this is 6 here, 6 negatives, 6 positives add up to 0. So this is called a oxidation half reaction. Each Ca is losing 2, so that's a total of 6. As a result, you have 3 Ca plus 2 ions. Now, if Ca is losing 6, that means Al plus 3 here, these 2 Al plus 3s are gaining 6 electrons. Pitch and catch. Ca0 is giving them to aluminum plus 3, and this is how we show it. So here, electrons are on the right side because they're being lost. Here, they're on the left side because they're being gained. Now, what do these two combine together to form? Right here, 2Al0. These are called half reactions. This is my oxidation half reaction. This is my reduction half reaction. And all you're showing here, if you really look and see what I'm doing, is you're taking your reactants here and you're just writing them on the left side of the arrows. You take your products and put them on the right side of the arrows. The only difference between this full reaction and the half is you have to show where the electrons are. In oxidation, they're always on the right because they're being lost. Just like exothermic, releasing, right? It's on the right. Endothermic is gaining, absorbing, right? Same thing. Reduction, gaining. It's on the left. So 6 electrons on the right, 6 electrons on the left, because if calcium's losing 6, aluminum plus 3 is gaining 6, and that balances the whole thing there, mass and charge. All right, that's it for that. Let me go to what's due tomorrow. So due tomorrow is this worksheet here, and I'll post it right after I'm done with this video. So I'm going to do the first one with you. Now, first of all, what I'm going to have you do is actually cross off the spectator ions. So I'll do this really quick here. So I'm going to get rid of the NO3s here, the CO3s, the PO4s, and the PO4s. Okay, so I'm going to have you just do 2 and 3. We're not going to even do 4. I'm going to do number 1 with you right now. All right, so here's how we do this. All right, so solids are 0, 0, right? We could go through and label 0, 0, 0, 0. Okay, all the aqueous ones have charges. My Cu has a +2 charge. How do I know that? Because there's a 2 here, and NO3, which I crossed off, is -1. So I know Cu is +2 because there's 2 NO3 minuses. So that must be a +2. That's something from the past that hopefully you remember. Fe must be +3 because that 3 is here. NO3 minus. So if there's 3 of them, this must be a +3. And you can do the same thing down here. All right. So you're going to have to look those up. This is CO3 -2. This is PO4 -3. All right. So, you know what? If you're watching, then added bonus here. I'll just give it to you. That's going to be AL's +3, Na plus. Those are easy. You can look them up on their periodic table. CR has a few different options: +2, +3, +6. I think +7 too, maybe. Here it's +3 because PO4 is -3, and Zn is always +2. So these 3 are actually, you can just look up in the box on the periodic table. This one you'd have to figure out. All right, so there, if you're watching this, there you go. Merry Christmas. All right, here we go. Got to balance. So I'm going to do this quick. You know what, and I'll do this with you quick, but again, I'm not too worried about it. Here we go. All right, +3, +2. The next number in common is 6, so I need 3 of those. 2 of those, that's +6, +6. 3 Cu, 3 Cu. 2 Fe, 2Fe. I feel like this can be smaller here. Oops. Here we go. All right. Okay, oxidation is going to be 2Fe0. Reduction 3 Cu plus 2. Why? Fe went from 0 to plus 3. It lost electrons, became more positive. Cu plus 2 gained electrons, became more negative. It reduced. It reduced. All right. So these are the it says put half reactions on the back. Just do them right here. So 2Fe0 yields 2Fe plus 3. How did it turn into 2Fe plus 3? It lost 6 electrons, just like my other example. And if Fe is losing 6, Cu plus 2 is gaining 6. As a result, turns into 3Cu0. If that's all you do on these two and 3, I'm fine with it. The oxidizing agent now is the one that gets reduced. What I mean, the one? Well, there's two reactants here. One of them is oxidized, one's reduced. Cu plus 2 is reduced, so therefore it's called the oxidizing agent. And because Fe0 is oxidized, it's called the reducing agent. Reducing agents get oxidized. I know that's confusing. If I feel like it, I'll talk about that tomorrow in class. All right. So this is what you're going to do on your homework. This exact worksheet due tomorrow. Just 2 and 3. I will go over those tomorrow. Then we're going to learn about cells. All right. I'll see you guys tomorrow.